All right, now let's have a quick little review of how to find an inverse. I'll do a couple of these. All right, so finding an inverse. Finding. I like how this program automatically switches back to black. Otherwise, I'd have a bunch of nasty stuff. Finding an inverse. Inverse f inverse of x. Well, again, hopefully you remember. First, switch x and y to solve for y, and then 3, y equals f inverse of x. So in the case of y equaled x squared, now I realize that this is y equals x squared is not 1 to 1, but what did we do? If I go x equals y squared, and I take the square root of everything, I get y equals plus or minus root x. Whoops, which we all did, right? So we chose the positive side, called the principal square root. So y equals root x, and that ended up our inverse. Okay? Now, let's do one that definitely has an inverse. Keep it simple. So what was my one before? I forget. Let's look real quick. I go here, 3x plus 2. I'll do an easy one, then I'll do a hard one. So f of x equals 3x plus 2. The thing to remember is that f of x is always equal y, right? So I'm going to go x equals 3y plus 2. And then I'm simply going to solve for y. So x minus 2 equals 3y. So y equals x minus 2 thirds. And this guy is my inverse. Nothing to it. Now what if it were a little bit sloppier? What if f of x, or not as pretty, I guess it doesn't have to be sloppy, equals x plus 2 over x minus 1. All right? So again, remember, f of x always equals y. I'm going to switch the x and the y, so I get y plus 2 over y minus 1 equals x. And then I'm going to solve. Now notice I'm doing mathematics. I'm doing algebra, so I'm not going to use equal signs. I'm going to use this implies arrows right here. All right? So I'm going to do y plus 2 equals xy minus x. I'm solving for y. Notice over here. It says solve for y. So I'm going to gather all my not y terms, this guy and this guy, on one side, and I'm going to gather all my y terms, this guy and this guy, on the other side. So I'm going to get y minus xy equals negative 2 minus x. Remember, respect thy negative. Negative 2 minus x. Sorry, my pen's a little crazy. I'm going to factor out a y, because I'm just trying to, all I'm doing is following the basic principles of Algebra 1. Bring your variable terms to one side, isolate the variable, and solve. So I get what? 1 minus x equals negative 2 minus x. And I end up with y equals negative 2 minus x over 1 minus x. And I'm going to do a puff of algebra here, which you're about to see. Let's see if we can figure out why it turns out this way. This actually ends up being x plus 2 over x minus 1. Why? Well, I factored a negative out of the bottom term, and I factored a negative out of the top term, and I canceled. And this is f inverse of x. Okay? So, this is my function. This is my inverse. What the heck? Oh my gosh. They end up being the same function. That's one of those crazy functions that is its own inverse. Now, why does that happen? Why does that happen? Wait. Let's prove it first. Remember, because you'll come across this. Hopefully you've seen this before. Again, we're just reviewing. If a function is if I want to prove that two functions are inverses of one another, then I do f of f inverse of x, and I know this is going to equal f inverse of f of x, and I get x back. Okay, so let's test it. If I take f of x plus 2 over x minus 1, and I'm going to plug this thing into this term, what will I get? I'll get x plus 2 over x minus 1 plus 2 over x plus 2 over x minus 1 minus 1. All I did, wherever I saw an x, I stuck this guy right here. All right? Now let's see what happens. This turns into what? X plus 2 plus 2x minus 2 over x plus 2, whoops, yeah, over, sorry about that. I keep reaching for my analog eraser. All right, and it's not happening. Over x minus 1, and then over x plus 2 minus x plus 1. Let's see, let's make sure I got that squared away. Something crazy happened there, didn't it? X plus 2 plus 2x minus 2. Right? Now I got that, and then x plus 2 minus x plus 1 all over x minus 1. Those cancel. I end up with, the 2's cancel, I end up with 3x over 3, affectionately known as x. See, even I can get screwed up in those. I was like, what? Wait a sec. I got too many fractions going on here. I want this to be red. I got too many fractions going on here. So you just take a deep breath, you slow down, and you double check it. I composed this function with this function. Now, there's a little caveat here. I chose this on purpose so that you don't panic if you see that a function is its own inverse. Okay? Excuse me. Another example of that we can talk about here in just a sec when we talk about the graphical ramifications of inverses. Not all rational functions. This guy right here is referred to as a rational function because it's a polynomial divided by a polynomial. Remember, r of x equals p of x divided by q of x. Let's talk about the graphical ramifications. Let me see if I can get us where we need to be. Oops, sorry guys. Every now and then this thing lags. All right. Oh, is it not going to let me? Hold on just a sec. Oh, I've only got that number of screens, so I'm going to have to erase a screen. Hold up just a sec. Sorry about that. All right, so I'm going to erase right here. Let's get rid of this one. Again, learning the software, so bear with me. Okay. Graphical consequences. Hopefully you remember, if I sketch f of x, and let's say fx, remember it's got to be 1 to 1, let's say f of x looks something like this. Think about it. What do you remember about the graph of its inverse? What do you remember? Well, it has everything to do with that property right there, that the composition of two functions always produces x. Well, again, the graphical ramifications of that is this guy is y equals x. Coincidence? I don't think so. Is going to be the line of symmetry around which these two functions wrap. So this is going to be f inverse of x. That is how inverses work. Now, think about what we just did. This is the cool part. We have a graphical idea about how inverses work. We have an algebraic way to deal with inverses. And then theoretically, we have, oh, I already erased it. We have a numerical way. We change our x's and our y's. So I could actually give you a chart of x's and y values, and you simply flip the x's and y's, and that gets you all squared away. Okay?